Hey, this is great. Later on, we're going to be joined by Angelica and Lucy, so I want to make sure that we have our game plan when we're meeting with them. As you know, we're going to be talking about how content can be linked across grade levels, and that's the real goal of those conversations. So what are some things that we want to make sure we highlight when we're talking to them?
Well, we definitely want to make sure that they're using the access model, that they're, cognizant about being clear in their lesson, culturally and linguistically relevant and responsive, right? So we got to make sure that we bring that up, definitely.
Exactly. And I want to make sure that we address the content from a progressive formalization DSF point of view so that we can see that the lesson is being developed or solidified in their stage of learning.
And we should also make sure we emphasize the RAC process so that there's a connection made. And when we're using the numbers that we pick, make sure that they're A, user-friendly, and B, that they progress in a way that will help students see what it is we're looking for.
And circling back, I think in the RAC process, we really want to help the teachers or elicit from the teachers situations that kids can represent so that we can ultimately analyze and make connections with. Anything else that we want to be thinking about?
No, I just think we should have the format in front of them so they can see it, the RAC format, so they know what we're looking for, and maybe talk through all of this before we get into it so that they can keep their vision focused.
Great idea. I think maybe, Enchante, you can pull up the RAC template.
Oh yeah, I'll definitely do the Google Doc and share it with everyone.
Yeah, when we're planning those lessons.
Yeah,
And
I'll be a note taker.
Right.
Great. Anything else? I think we got it, right?
Yeah.
It's pretty much the game plan, and looking forward to meeting and working with Angelica and Lucy. So
Good.
let's go to it.
All right.
Good afternoon. Thank you for coming to our RTC meeting for the responsive teaching cycle. And we have today Angelica, who's teaching algebra from high school, and Lucy, middle school teacher. And the purpose for our meeting today is to really look across the grade levels, to think about the math that cuts across these grade levels and how we can work together as a team to build continuity. So often, as you know, that the textbooks are very disjointed and the content is taught in very siloed ways. And we want to make sure that kids can see the continuity between these ideas. So let's get to it. What are some topics that you think are super important that kids need? Well, I'll start with Angelica, that you see kids struggling with in algebra, and then maybe we can backwards plan around Lucy to see how we can support that.
I think a huge concept that algebra kids have trouble with is slope. If I give them a graph, they always get the up and down, the left and right confused. If I give them a table, they don't know which column to add, X or Y. If I give them the equation, they mess up. So for example, if I give them y equals 3x plus 5, they don't know which one's the slope.
Right. So Lucy, in sixth grade, where you're teaching, where does slope come up, right? How is slope presented in sixth grade?
Well, we talk about unit rate in sixth grade. We don't really get into slope, or the idea of slope, but we do talk about unit rate. And when Angelica was sharing her struggles, that's also something that sixth graders struggle with, is just understanding, the differences between a ratio and a rate, and then, finding out the proportion or the relationship in these quantities that way. So I think that's a good place to start.
So it does sound like this is a topic that is worth exploring and thinking about planning some lessons around to build that foundation in sixth grade, and then taking it to algebra and really fleshing it out and deepening their understanding around this idea of slope, because they are connected, right?
What are the stories or whatever that they're using to relate this mathematics to, or if there are any? Because sometimes we teach them how to graph, but it's like we're graphing for graphing's sake. Why, you know? And so maybe if we could be extra careful to be clear and make sure that the context that we're giving them are relevant, you know, and that they're culturally appropriate as well. You know, our students, they have certain interests, and so maybe we can bring some of those into the lesson to help them engage with it as well.
Excellent. Okay, so based on this conversation, I think we have a good idea of where to begin. What are some other things that we should be noting? And I appreciate that Enchante brought up making the lessons clear, culturally and linguistically relevant and responsive. So having contexts that kids can relate to. What is multiple representations? What else?
Making the numbers user-friendly so that it's easy for them to focus on the concept rather than dealing with numbers that create problems for them mathematically, for example, large fractions or large numbers.
Good afternoon. Gosh, it's good to have you back. Remember last time when we met with Angelica, we were talking about the connection between concepts in middle school and high school, and if I recall, you were interested in working on this idea of unit rate. So let's start there and think about how we could build lessons around this idea of unit rate. Our clear context is comparing what's a better deal of what?
Takis and hot Cheetos.
Why Takis and Cheetos?
It's what they're not allowed to bring in school. They always have it in their backpacks, always have it during nutrition.
I would never have done that as a student.
And I love Takis and hot Cheetos too, so
Oh, okay, it's personal.
it's personal.
So let's start with,
Takis.
okay, Takis. Sounds
Way to
good.
go, tacos.
Fuego Takis.
Well, if we're gonna do it, we're gonna do it right.
And then we're gonna do flaming hot Cheetos.
Of course, the
Right.
ones that
Flamin'.
catch on fire.
Flamin'.
You keep adding that G, flamin'.
Okay, flamin'. Okay. So let me put this
It's a
down
good
so I don't forget.
misconception.
Hold on. You're saying that, what was the first one? 5?
5 bags for $4.
So I'm just gonna write 5 bags for us so that we can keep track. $4, right? And then the other one you said, Bob, was
6 for $5.
6 bags for $5. I know, I use the words. You were saying what? That
Well, the students might go, oh, so for an extra $1, I get an extra bag. So therefore, each bag must cost $1. And that's a very common misconception. Their inability to understand what's actually happening.
That's a great point, because the thing about proportional reasoning is it's multiplied and not added. And a lot of kids get that
Oh,
mixed up.
yeah.
So this is really good. And if they make this error and they start thinking that way, and we can anticipate that they will, and in fact, I hope they will, then how do we address it, right? How do we test their theory without just saying wrong, but test it to see if it's correct? Like, what can we do?
Well, that's what you said earlier, double it. So then if they're doubling it, it's multiplying it by 2, not just adding 1
Right.
more or adding 3 more or whatever.
And then we can see if doubling it is the same as just keep adding until, let's say we double this one. And this one is 10 bags.
10 for 8.
If we doubled it, it would be 10 bags for $8. And then
Keep
we
going.
can keep adding here and see if that's,
Yeah. Or
Right.
like you said, give them the 20. Okay, so now you have $20. How many bags of Takis can you get at
a good
7-Eleven
point.
versus
yeah.
whatever other store?
And then earlier, Bob, you said you wanted to show a different situation.
So just flip it. So now we want to give them how much it costs. So now we're giving them dollars to bags.
Oh, okay, so same numbers?
Yes.
You can do the same numbers.
$5 for
For
4
4
bags. $6 for 5 bags.
Uh-huh.
Okay, like what, Cheetos,
Flamin' hot Cheetos.
oh, that's right,
is when you
Flamin'
bring
hot
it
Cheetos.
Don't forget the G. There's no G.
No
No
G,
G.
no G, okay, even though I'm OG, no, just, anyway, I think we're ready. This is
Cool.
good, thank you so much.
Yeah, thank
Great
you.
Good job,
ideas.
Lucy.
Good job, Lucy.
Thanks.
I recall last week when we were talking that you mentioned that some of the confusion for kids is that they, and correct me if I'm wrong, that they were unable to see like slope or rate of change in the graph, or they're not able to see it in the table, and they kind of just know the procedures for getting the answer. So let's think this through. We want to set up the situation of Mario Kart racing between Mario and Luigi, and we have these rates, and we're going to ask kids to analyze who's faster. No, not who's faster.
Well, we gave them a rate, and so then you were saying, if given that rate, can they figure out how many laps they're doing in a certain time?
Right. How many
Right.
laps can they do in 12
Like we
minutes?
said, 12 minutes, right?
12 works. That's reasonable.
Okay, but, all right, that's great, I like that. But that doesn't require them to use unit rates, they can just
No.
use reasoning,
Exactly.
right? We should think of a number that they would have to use a unit rate to ultimately compare.
Or they'd have to use some more reasoning anyway, right? So like we were talking about how 6 and 12 are multiples, so how about using a number that's not an even multiple of both of them? Like 15 or, something,
So 15 laps,
right?
what do you think?
I think that works because maybe for Luigi, they can probably multiply because 15 is divisible by 3. But with Mario, they would have to do some extra reasoning, maybe make a table, a graph. They have to do something else.
Or go to the unit rate.
I was just going to say,
Yeah.
the advantage of that is then it will kind of lead them to unit rate because they can't do it in their head by multiplying, as you just said. So I like that. 15
So
is
let's
good.
capture that in our rack lesson. We want to compare, right? Do we want to use the same numbers? Because this is part of the analysis, or do we want to use some different numbers on the graph on Desmos? Because then we're just revisiting the same thing.
I think we could. I
Okay.
mean, because it's about analyzing and comparing, contrasting the different representations.
So we
now,
want,
so, yeah.
what do we want?
So Mario's driving 4 laps in 2 minutes.
Okay, so for
And
example,
so-
Mario and say Luigi, right? I don't know who's who. So let's just say we got Mario and Luigi. Like that, right? And then what do we ask them to do with this graph? We want them to analyze it and answer some questions. What questions can we ask?
How many laps will Mario drive in 12 minutes?
Oh, okay, so this is not 12 minutes, right? This would be, let's say, the 2-minute thing that we said.
Right, what we gave them.
So then they could, we can make this a sliding point and they can slide it out or wherever they want, right? And then they can say, oh, okay, at 3 minutes it's here, at 12 minutes it's there.
I kind of like that because maybe they'll see that it's the same rate going once they're playing
Oh,
around
it's the
with
same
it.
line, right?
Yeah.
Yeah. And then we want a table probably next to it, right? Don't we want like a table?
Right.
So that they can actually plot the points? So 0 is 0, because these are proportional relationships. 1, and this would be like Mario.
I was just about to say we need Mario and Luigi
And we
at the
need
table.
Luigi, right?
Yeah.
So that's a good idea. So 0, 0, 0. So 1, Mario would be, what's his number? 2?
2.
One,
This is
two.
2 per, okay. And Luigi is
3.
3. And then 2, this would be 4, this would be 6, right? And they fill it out, or we, no, yeah, they fill
They
it
should
out.
fill it out.
So they use the slider, and then they fill out the points. Okay, so then what?
Eventually you want to get them to the equation.
Are they ready to write the equation here? Because I think there's a missing step. I think the other step in between, which is what Angelica was getting at, is what is that rate? What is the slope? And they have to see it here and see it here.
So we
right?
have to ask some guiding questions that help them to recognize that.
Explicitly
Right.
notice it between here and here,
Right.
correct? Okay, so we could definitely ask those questions. Can we write down those questions on the rack lesson so we can have it in our heads? You have the rack lesson, you'll make the Google Doc that the kids will work on, and if you want, I can make the Desmos and get that.
That works.
So I think we have a game plan. I
Definitely.
think this is definitely something that can work, and I really like the comments that you guys made. This is awesome. I love how we collaborate together in this RTC. Thank you.
Good job.
and look where we are now.
Right,
right?
absolutely.
Hilarious.
Should have let me quit when you could.
Well, I don't know about that.